In the 1950s, a new era of scientific inquiry began: the systematic measurement of carbon dioxide, or CO2, in the atmosphere. This was a time when the world was rapidly changing, with technological advancements and industrial growth reshaping societies. Amidst this backdrop, a group of pioneering scientists embarked on a mission to understand the invisible gases that envelop our planet. This marked a turning point in our understanding of the planet, as scientists started to unravel the intricate link between CO2 levels and Earth's climate. They meticulously collected data, analyzed samples, and began to piece together a picture of how human activities were influencing the natural world. Their work laid the foundation for modern climate science. Before this, CO2 was often dismissed as just a byproduct of industrialization, its potential impact on the planet largely unknown. Factories belched smoke into the sky, and the idea that these emissions could alter the climate was not widely considered. The prevailing belief was that the vastness of the atmosphere could absorb any amount of pollution without consequence. The International Geophysical Year of 1957 to 1958 provided the impetus for a global effort to study the Earth's systems, including the atmosphere. This ambitious project brought together scientists from around the world, united by a common goal: to understand the planet's complex and interconnected systems. It was a time of unprecedented collaboration and discovery. Scientists established monitoring stations in remote locations, far from industrial centers, to obtain baseline measurements of CO2. These stations were strategically placed to ensure that the data collected was not influenced by local pollution sources. The goal was to capture a true representation of the Earth's atmospheric composition. One such station, perched atop the Mauna Loa Observatory in Hawaii, would become a cornerstone of climate science. The observatory's remote location and high altitude made it an ideal site for monitoring atmospheric CO2 levels. The data collected here would prove to be invaluable in understanding long-term trends. The data collected from these early monitoring efforts revealed a startling trend. CO2 levels were steadily increasing. This was a groundbreaking discovery, as it provided concrete evidence that human activities were altering the composition of the atmosphere. The implications of this finding were profound and far-reaching. This discovery, while alarming, was just the tip of the iceberg. Scientists began to realize that the increase in CO2 levels could have significant impacts on the Earth's climate. They hypothesized that even small changes in atmospheric composition could lead to shifts in weather patterns, temperature, and sea levels. Scientists were beginning to realize that even small changes in CO2 concentrations could have profound consequences for the Earth's climate system. They presented their findings at conferences, published papers, and engaged in discussions with their peers. The scientific community was abuzz with the implications of these discoveries. The stage was set for a new era of climate science, one that would forever change our understanding of the planet and our role in its future. Researchers began to develop early climate models, using the data collected to predict future trends. These models would become essential tools in the study of climate change. The invisible threat of CO2 was no longer invisible, and the world began to pay attention. Public awareness campaigns were launched, and the media started to cover the issue more extensively. The work of these early scientists laid the groundwork for the global climate movement, highlighting the urgent need to address the challenges posed by rising CO2 levels. In 1958, Charles David Keeling, a young scientist at the Scripps Institution of Oceanography, began collecting CO2 measurements at the Mauna Loa Observatory. This remote location, situated on the slopes of a Hawaiian volcano, was chosen for its isolation from local pollution sources, providing a pristine environment for accurate atmospheric readings. His meticulous data collection and analysis would give rise to what is now known as the Keeling Curve, a stark visual representation of the relentless rise of atmospheric CO2. This graph, with its unmistakable upward trend, has become one of the most iconic images in climate science, symbolizing the growing impact of human activities on our planet. The Keeling Curve is not just a graph, it's a testament to scientific dedication and a stark warning about the future of our planet. Each data point on the curve represents a moment in time, a snapshot of our atmosphere's changing composition, and a reminder of the urgent need for action. Year after year, the Keeling Curve has traced an upward trajectory, mirroring the increasing CO2 emissions from human activities. Industrialization, deforestation, and the burning of fossil fuels have all contributed to this rise, altering the delicate balance of our atmosphere. Initially, CO2 levels hovered around 315 parts per million, a figure that had remained relatively stable for millennia. This stability was a testament to the Earth's natural regulatory systems, which had kept atmospheric CO2 in check for thousands of years. However, by the 1960s, the Keeling Curve began to show a clear and alarming trend. CO2 levels were rising at an unprecedented rate. This marked the beginning of a new era, one in which human activities were having a profound and measurable impact on the global environment. The Keeling Curve became a powerful tool for scientists and policymakers alike, providing irrefutable evidence of human impact on the planet's atmosphere. It has been used in countless studies, reports, and presentations, helping to shape our understanding of climate change and inform policy decisions. It shattered the illusion that the Earth's systems were too vast to be affected by human activities. The data collected by Keeling and his successors revealed the interconnectedness of our actions and the environment, highlighting the need for a global response to this global challenge. The invisible threat of CO2 had become visible, and the world could no longer ignore the implications. Rising CO2 levels are linked to a host of environmental issues, including global warming, ocean acidification, and extreme weather events, all of which pose significant risks to ecosystems and human societies. The Keeling Curve stands as a stark reminder of the legacy we are creating, a legacy etched in the very air we breathe. It serves as a historical record of our impact on the planet and a call to action for future generations to address the challenges we face. It is a call to action, a plea for responsible stewardship of our planet, and a testament to the power of scientific observation in revealing the hidden truths of our world. The Keeling Curve continues to inspire and inform, reminding us that the choices we make today will shape the world of tomorrow. As we look to the future, let us heed its warning and work together to create a sustainable and resilient planet for all. The reason even small changes in CO2 levels are significant lies in the very nature of our atmosphere. Our atmosphere is a delicate balance of gases that work together to maintain the conditions necessary for life. Even minor alterations in the composition of these gases can have profound effects on the climate and consequently, on all living organisms. One of the key processes influenced by these gases is a phenomenon known as the greenhouse effect. This effect is crucial for maintaining the Earth's temperature and supporting life as we know it. This natural process, essential for life on Earth, works by trapping some of the sun's heat, keeping our planet at a habitable temperature. The sun's energy reaches Earth in the form of sunlight, which warms the planet's surface. Without the greenhouse effect, Earth would be a frigid, uninhabitable wasteland. The average temperature would plummet, making it impossible for most forms of life to survive. CO2, along with other greenhouse gases like methane and water vapor, acts like a blanket around the Earth. This blanket is essential for trapping heat and maintaining the planet's temperature. These gases allow sunlight to pass through the atmosphere, but trap some of the outgoing heat radiation that would otherwise escape back into space. This trapped heat is what keeps our planet warm enough to support life. This trapped heat warms the planet's surface and lower atmosphere, creating the temperate conditions we rely on. The balance of this system is delicate, and even small changes can have significant impacts. The problem arises when the concentration of greenhouse gases in the atmosphere increases. Human activities, such as burning fossil fuels and deforestation, have led to a significant rise in these gases. This enhanced greenhouse effect leads to a greater trapping of heat, causing the planet's average temperature to rise. This rise in temperature is not just a minor inconvenience, it has far-reaching consequences for the entire planet. This seemingly small shift in the Earth's energy balance is the driving force behind climate change and its cascading consequences. These consequences include more frequent and severe weather events, rising sea levels, and disruptions to ecosystems. While the greenhouse effect is a natural and essential phenomenon, human activities, particularly the burning of fossil fuels, have significantly increased the concentration of CO2 in the atmosphere. This increase has disrupted the natural balance and accelerated the rate of climate change. This disruption of the natural balance is what has led to the current climate crisis. It is a crisis that requires immediate and sustained action to mitigate its effects and protect the future of our planet. By understanding the importance of small changes and their cumulative impact, we can take steps to reduce our carbon footprint and work towards a more sustainable future. The impacts of increased CO2 levels are not just theoretical projections, they are already being felt around the world. Climate change is no longer a distant threat, it is our present reality. The rising tide of CO2 is manifesting in a myriad of ways, from more frequent and intense heat waves to rising sea levels and extreme weather events. One of the most visible and devastating impacts of climate change is the increase in extreme weather events. Hurricanes are becoming more powerful, fueled by warmer ocean temperatures. Droughts are becoming more frequent and severe, decimating crops and displacing communities. Coastal areas are facing the dual threat of sea level rise and more intense storms, putting lives and livelihoods at risk. The impacts of climate change are not evenly distributed. Vulnerable communities, often those least responsible for CO2 emissions, are bearing the brunt of the crisis. Small island nations face an existential threat from rising sea levels, while communities in arid regions struggle with prolonged droughts and water scarcity. The real-world impacts of CO2-driven climate change are a stark reminder that we are all connected to the planet's delicate systems. What we do in one part of the world can have ripple effects that are felt across the globe.